Convolution in time domain. How can we find the Fourier transform if there's a signal convoluted on the other signal? Usually, the application of convolution, if you have a linear time system and defined by the impulse response h of t, and you have the input x of t, and you want to find the output y of t, so we'll say y of t is equal to x of t conjugated on h of t. And if you remember, when we did that in time domain, we did by integration of x t minus lambda, h lambda, or tau d lambda. But in Fourier transform, to do the convolution is really easy. You find the Fourier transform of the input signal x of t, that will be x of omega, and find the Fourier transform of the impulse response h of t will be h of omega, multiply, then you get the response in frequency domain. Okay, let's take an example. Okay, in this example we have a linear time system defined by the impulse response e to the power of minus 2t u of t, and the input is unit step. So that's what we have. We have impulse response look like that, and we have an input which is unit step. So what is the output? We'll use convolution. So we'll say y of t is equal to x of t convoluted on h of t. In this case, x of t is equal to u of t, and the impulse response h of t is equal to e minus 2t u of t, according to Fourier transform. For convoluted signals, we'll find first x of omega, which is corresponding to the unit step. We'll go for the table. We'll find that the unit step has the following transformation: pi delta of omega plus 1 over j omega. That's the unit step. Great. So what about the impulse response in frequency domain h of omega? That's e minus 2t ut, we did it many times, will be equal to 1 over j omega plus 2. So we have the input, we have the impulse response, and now we'll find the output by multiplying both. Will be equal pi delta omega plus 1 over j omega multiplied by 1 over j omega plus 2. Let's now multiply term by term. Pi delta omega times 1 over j omega plus 2. Second term, 1 over j omega multiplied by 1 over j omega plus 2. I will rearrange the first term in this way: pi over j omega plus 2, all multiplied by delta omega. Second term, 1 over j omega multiplied by j omega plus 2. I will simplify each term separately. I'll take the first term. And remember the property of impulse. If you multiply any function of omega by unit impulse, that would be equal to the function when you put omega equal to 0 multiplied by delta omega. That's one property of the impulse response when you multiply it by a function of omega. In this case, we can write the first term pi over j omega plus 2, that's the function, times delta omega will be equal to this function when omega equals 0, pi over 2 times delta omega. So that's the first term. Second term, that's the second term, 1 over j omega multiplied by j omega plus 2, j omega multiplied by j omega plus 2. We said that this will be easy to use partial fraction. But before we do partial fraction, let's just call j omega by s. So to make it just simple when we are solving. So j omega here will be s. J omega plus 2 will be s plus 2. And again, we'll try to convert this product into sum using partial fraction. So 1 over s plus 2, and we have a constant a, constant b. We need to find them. How to find them? Okay, just try to find a common denominator. For example, the first one, a over s, so multiply s plus 2, s plus 2. Second term, s plus 2 multiplied by s in the top, s in the bottom. Now we have both denominators the same. Now we have a common denominator. So we may write it like that. Common denominator, s times s plus 2. And you have in the top a times s. A times 2 is 2a. S times b, bs. So rearrange terms. S times s plus 2. In the top as and bs, so you take it as a common factor. A plus b times s plus 2a. What do you have on the other side? You have 1 over s plus 2. This constant equal this constant. This is the constant, 2a. So you have 2a is equal 1. From that you get a is equal half. So that's the first one. What about a plus b? That's the coefficient of s, but you don't have s here. You can write 0 times s plus 1. This is like nothing. So 0 is equal to a plus b. From that equation, you can say b is equal negative a, but a is equal half. So b is equal negative 1/2. We got both. We'll go back to the partial fraction. This is a partial fraction, and then instead of this expression, you have a over s plus b over s plus 2. Here you go. So 1 over s plus s over 2 equal a, which is equal 1/2 over s minus 1/2 over s plus 2. And if you take 1/2 as a common factor, so you have 1 over s minus 1 over s plus 2. Now you have back s as j omega. So that's the second term. You have the second term and you have the first term. So the total output in frequency domain omega equal the first term, I forgot, pi over 2 times delta plus the second term, we have it here, 1/2 times 1 over j omega minus 1/2 1 over j omega plus 2. That's the total response in frequency domain. Most of the time, we like to convert from frequency domain to time domain so we can know what the look like, the response. So all what you're supposed to do, supposed to go to the table and check for everything that you have there. For example, you have pi over 2 times delta omega, all right, plus 1 over 2, 1 over j omega. You look for the table there. You can take 1/2 as a common factor for here, for everything really. So you have pi delta omega plus 1 over j omega minus 1 over j omega plus 2. When you look at the table, you'll find there's something there. Let me just change the color. In the table, it said that the unit step function pi delta omega plus 1 over j omega. When you compare, you'll find that the first two terms. All right. And we know that e to the power of minus 2t u of t has Fourier transform equal to 1 over j omega plus 2. So we have everything ready. So you can say y of omega will be equal 1/2. And the first two terms will be equal to what we got here, which is what u of t. Sorry, now we are finding the inverse. Should be like y lowercase of t equal to 1/2. Then you have unit step for the first term, the second minus e minus 2t ut. And that will be, you can take u of t as a common factor also. So you have 1/2 1 minus e minus 2t u of t. That's the response in time domain. And you can make a sketch, rough sketch. It means if you have the input as a step and the impulse response or the system look like that, e minus 2t ut, that's the system, and this is the input x of t equal unit step. So the output will be this equation. It will look like that. If you put t equal to 0, first of all, it's multiplied by ut. It means before 0 is equal 0. And now, when you put t equal 0, e power 0 equal 1, it's 0. When you put t infinity, e power minus infinity is equal 0, 1 minus 0 is equal 1/2. So, in the end, will rise easily and then reach to 1/2 in the end. So that would be the output. And that's it.